Hello everyone, I'm Yusuf Jamal. In this video, me and my group will explain some of electromagnetic devices. First of all, what is an electromagnet? Electromagnet is a type of magnet in which the magnetic field is produced by an electric current. Usually, electromagnets consist of a wire wound into a coil. A current through the wire creates a magnetic field, which is concentrated in the center of the coil. The magnetic field disappears when the current is turned off. The wire turns are often wound around the magnetic core, made from a ferromagnetic material, such as iron. The magnetic core concentrates the magnetic flux and makes a more powerful magnet. In everything, there is a main advantage. And the main advantage of an electromagnet over a permanent magnet is that the magnetic field can be quickly changed by controlling the amount of electric current in the winding. However, unlike a permanent magnet, an electromagnet requires a continuous supply of current to maintain the magnetic field. Electromagnets are widely used as components of other electrical devices, such as motors, generators, electrochemical solenoids, and relays.
And now, Ahmed will explain the uses and framework of electric bulb.
Many objects around you contain electromagnets. They are found in electric motors and loudspeakers. Electric bells, like the ones used in most schools, also contain an electromagnet. So, electromagnet plays an important role in electric bells. An electric bell is a mechanical or electronic bell that functions by means of an electromagnet. When an electric current is applied, it produces a repetitive buzzing, clanging, or ringing sound. They are typically designed to operate on low voltage from around 5 to 24 volts AC or DC. There are different types of electric bell, such as interrupter bells, buzzers, single-stroke bells, telephone bell, and fire alarm bells. The most widely used form is the interrupter bell, which is a mechanical bell that produces a continuous sound when current is applied. Electromechanical bells have been widely used at railroad crossings, in telephones, fire and burglar alarms, as school bells, doorbells, and alarms in industrial plants since the late 1800s. Vibrating hammer interrupters were invented by Johann Philipp Wagner in 1839 and Christian Ernst Neff in 1847. John Miranda around 1850 added a hammer and a gong to make the standard electric bell for use as a telegraph sounder. An interrupter bell consists of one or more electromagnets made of a coil of insulated wire around an iron core, which attract an iron strip armature with a hammer at its end, striking a gong that is pulled back with the help of a spring. Other parts include soft iron yoke that attaches the electromagnets, landing spring that makes the landing smoother and allowing for the flow of current, contact adjusting screw to adjust the time intervals between contacts, and without mentioning that the bell is connected to an electric source. Let's dive in deeply into the framework. When the switch is pressed, the circuit loop is complete, which causes the current to flow through the circuit. This powers the electromagnet. The electromagnet generates a magnetic field that attracts the armature towards it, causing the hammer to strike the gong. This is the moment you hear the ringing sound since the hammer hits the gong. When the hammer arm strikes the gong, the contact is broken and current stops flowing through the circuit. This causes the electromagnet to lose its magnetic field. The connected spring arm pulls the striker back to its original rest position, restoring the contact and making the current flow through the circuit again, provided the main switch is still pressed. This process is repeated from the beginning, thus a repetitive ringing sound is achieved as long as the switch is pressed.
After you have heard the explanation given by Ahmed, Mohammed will deliver his message of circuit breaker with the uses and framework.
All of us live and work in where electricity plays a part in everyday's life, so more precaution should be taken. One of the main devices are circuit breakers. An early form of circuit breaker was described by Thomas Edison in 1879. Patent application, although his commercial power distribution system used fuses. Its purpose was to protect lightning circuit wiring from accidental short circuit and overloads. A circuit breaker is an automatically operated electric switch designed to protect an electric circuit from damage caused by excess current from an overload or short circuits. Unlike a fuse, a circuit breaker can be reset either manual or automatically to resume normal operation. Circuit breakers are made in varying sizes, from small devices that protect low current circuits up to large switchgear designed to protect high voltage circuits. The generic function of a circuit breaker or fuse is often abbreviated as OCPD, Overcurrent Protection Device. This is a circuit breaker. Our team has worked day and night for this animation to come true. It's one of the simplest type of circuit breaker we could find. Other types include like the one we learned, but let us focus on a more practical version. The functional parts of this circuit breaker includes an electromagnet, springs, contacts on an armature, and a reset button. The current from the power supply comes in from the right and goes out through the left. The current flows in a coil of wire which has a soft iron core inside it. So when current flows through the coil, an electromagnet is formed. The strength of the electromagnet is directly proportional to the amount of the current flowing through the coil. If the current grows too large, the electromagnet becomes strong enough to attract the side of the contacts closest to it, exceeding the spring's tension on the armature, thus make it rotate with the help of a pivot. As this occurs, the contacts completing the circuit are broken, and the current stops flowing. The springs helps to maintain the position of the armature, since the electromagnet won't attract it after the circuit has been broken. So after the amount of the current flowing has been adjusted, you can reset it manually by pressing the reset button. This resets the position of the contacts, thus completing the circuits again.
Now, Fahad will give us the uses and advantages of electric DC motor.
Have you ever wondered how your car or toy moves, or how the huge ships or trains start moving, either directly or indirectly? It is all because of a device that works with the help of electromagnet, that is the DC motor. A direct current DC motor is a type of electrical machine that converts electrical energy into mechanical energy. It uses electricity and a magnetic field to produce force, which turns the rotor and hence the mechanical work. DC motors operate on Faraday's principle of electromagnetism, which says that a current carrying conductor experiences a force when placed in a magnetic field. While the principles are the same across variants, there are actually several types of DC motor, which offer specific advantages and disadvantages over each other. The four main types of DC motor: brushless DC motor, brushed DC motor, shunt DC motor, and series DC motor. But here in this section, we will just concentrate on the brushed DC motor. Thanks to different types of DC motors available, there are wide variety of applications for DC motors. At home, small DC motors are used in tools, toys, and various household appliances, such as electric fans, electric toothpaste, vacuum cleaner, washing machine, etc. In retail, the applications of DC motors include conveyors and turntables, while in industrial setting, large DC motors uses also include braking and reversing applications. In agricultural settings, DC motors takes pressure off of humans and animals in order to perform tasks quickly and easily, such as pumping water or distributing grain. Hydraulic pumps are essential industrial tools which are used in almost all industries including construction, mining, manufacturing, and steel. DC motors can operate directly from rechargeable batteries, providing the motive power for the first electric vehicles and today's hybrid cars and electric cars.
Osama will explain the framework of electric DC motor.
A DC motor. This amazing piece of electrical equipment has revolutionized our life in many ways and has made many things that was impossible to become real. But who invented the DC motor? As with all major inventions, there are many people who had a role to play through the development of similar mechanisms. History was made when Thomas Davenport of Vermont invented the first official battery-powered electric motor in 1834. This was the first electric motor that had the power to perform a task, and his invention was used to power a small-scale printing press. In the same year, a Russian engineer, Morty John von Jacobi, went to invent the first rotating DC motor. His invention became famous for being incredibly powerful, which later set a world record. His motor was 3 times as powerful as that one Davenport would later patent, whilst Brandes Stratton was the first to demonstrate a practical application for an electric motor by running a small model car. Some years later, in 1886, by Frank Julian Sprague, whose invention led to the first motor power trolley system in 1887 and the first electric elevator in 1892. Sprague's DC motor was a hugely significant development, leading to a variety of applications which would reshape the fate of industry and manufacturing. As we know, there are four main types of DC motor, which Fahad have explained earlier. But now we will logically understand the operation and the construction of the commercial DC motor. Now let us see the simplest DC motor possible. The main parts of DC motor include two permanent magnets of opposite pole called the stator, an armature, a commutator, and a curb brushes. It looks like this. The stator provides a constant magnetic field, and the armature, which is the rotating part, is a simple coil. The armature is connected to a DC source through a pair of commutator rings. When the current flows through the coil, an electromagnetic force is induced on it according to the Ampere's law. You will notice that as the core rotates, the commutator ring connected to the power source will change polarity. As a result, on the left side of the coil, the current will always flow away from the commutator and the force action will push the coil downward. And on the right side of the coil, the current will always flow toward the commutator and the force action will push the coil upward. This ensures that the torque action is also in the same direction throughout the motion, so the coil will continue rotating in a counterclockwise. But if we observe the torque action on closely, you will notice that when the coil is nearly perpendicular to the magnetic field, the torque action is equal to zero. As a result, there will be an irregular motion of the rotor if you run such a DC motor. Here is a way to overcome this problem. Add one more loop to the rotor with a separate commutator ring for it. In this arrangement, when the first loop is in a vertical position, the second loop will be connected to the power source so that motor force is always present in the system. Moreover, the more number of the loop, the smoother the motor rotation. In a practical motor, the armature loop are fitted inside a slot with highly permeable steel layer. This will enhance the magnetic flux interaction. Spring-loaded commutator brushes will help to maintain contact with the power source. A permanent magnetic stator pole is used only for very small DC motor. More often, an electromagnet is used.
The field coil of an electromagnetic is powered from the same DC source. The field coil can be connected to the rotor winding in two different ways, that is, the parallel or the series connection. We can also use an axial fan attached to the rotor of the motor that spins with the motor, providing an increased airflow to the motor's internal and external part, which aids in cooling it.
Summary: Electromagnetism is a branch of physics involving the study of the electromagnetic force. It is a type of a physical interaction that occurs between electrically charged particles. An electric bell consists of one or more electromagnets made of coils. The electromagnet creates a magnetic field which pulls the armature towards it, causing the hammer to strike the bell. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. A DC motor is any of a class of rotary electrical motors that converts direct current electrical energy into mechanical energy. The most common types rely on the forces produced by magnetic fields. Thankfulness to our group members who seamlessly worked hard for this to come true. Greeting from our group and thanks for your watching.